everyone, today I am going to show you how to create procedural herringbone pattern inside Houdini. To design this particular pattern I am using Wax, and for material I am using material X. So before we jump into Houdini, I would like to show you the mathematics behind this particular pattern. So this is the structure of pattern, and as I always say that whenever you design something procedurally, you have to remember two things: that what we have. Likewise, in this particular example, we will have tile width and tile length that we basically insert manually, as well as we have numbers of columns. This is 1, 2, 3, 4, and numbers of rows 1, 2, 3, 4, 5, 6, 7, 8, like that. As well as we need to know that whenever we using this particular pattern, herringbone pattern, we have this 45-degree angle for this diagonal pattern of herringbone. So that angle is 45 degree, that we know. Okay, so this information we have. Now the next thing, that what we need. Okay, so what we need position of this tiling. Like this position should we know, we need to figure out, as well as we need to find out the direction of those tiles. Okay, so these are two tasks that we need to figure out. So let's start with our vertical spacing between two tiles. So if I project this vertical spacing over here in this particular area, and definitely we also need to identify offset, as alternative pattern has a bit offset. Likewise over here, same position, same y coordinate, we can say that maybe y or z, and here we need get little offset. So that we also need to find out. So we consider this triangle. So this is my width of my tile. So definitely this is also width, and this is 45 degree. So if I apply trigonometric function on it, so vertical spacing is equal to width divided by sine 45 or cos 45, because both has same value. And definitely offset. So offset is half of your vertical space. Okay, so these two things we need to remember, that okay, vertical spacing is equal to width divided by sine 45, and offset is vertical spacing divided by 2. Now whenever you are going to use Wax, we may need to remember that here I just define this particular angle in degree format. Over there we have to use radian format. Okay, that we will take care. Now next thing, we have to find out horizontal space between two tiles. So that is, like if I consider this triangle where we have this particular length is your length, half of your tile length. Okay, and definitely this is 90 degree, this is 45 degree. So based on that, horizontal spacing is equal to half of your length of tile divided by sine 45. Okay, so we just figure out the calculation behind vertical and horizontal spacing. Now next step that we need to find out is the direction of tile. Okay, so it is very easy. Likewise here we have this direction, and here we have this direction. So we need to find out normal direction. Okay, so technically it should be 0.707 in x, in y0, and in z 0.707. This is equivalent to sine 45, cos 45, like that. And here we have minus 0.707, 0, and 0.707. So this is normalized vector information, but we can avoid that for this example, and we can set like normal direction is 101 or minus 101. So over here 101, and over here minus 101. Okay, as it is 45 degrees, so we are not worried about that. But if in case we have 30 degree or 60 degree, at that time we have to calculate in a proper manner, like sine 60, sine 30, like that. Okay, so now we have those calculation. So let's move into Houdini and start with Vex to generate this point cloud for this herringbone pattern. So in Houdini, I just need to create one geometry container. I just name it as H pattern, that is for herringbone pattern. Go inside this container, and now I need to create one attribute wrinkle. As we need to generate our point cloud entirely from scratch, it is always preferable and it is always recommended that we have to run our Vex on detail. Now I'm going to start writing my expressions. So first of all, what we need to do is that we need inputs. That is your length of your tile, length of width of your tile, then numbers of column, numbers of row. So for that reason, we just apply float your tile length is equal to chf length. Next, we need to define tile width is equal to chf width. Then next, we need to define numbers of column and row. So that should be an integer. So I just write down number of columns is equal to chi num columns and integer num rows is equal to chi number of rows. Okay, and to run this particular parameter or to execute this parameter, I just need to click onto this button. So now I will get this length, width, numbers of column and numbers of row. So in this case, maybe I just put a value like 1.3, maybe here 0.2, here maybe 10 by 10. Okay, so we just insert some information so that we can easily get okay what is impact over here in your viewport. And it is preferable that right now I just change my viewport on top view by pressing spacebar 2, so I will get a proper idea about that. As well as here I need to create one grid that represent my tile, and in that I just need to copy this length, copy parameter, come over here in your grid parameter, paste relative reference, go again into your attribute wrinkle, copy parameter of width, again select grid, in parameter just paste relative reference. Okay, so now I get these tiles like this, and definitely I just need to change my row segment, and this should be 2 by 2. Okay, so minimum segment I need. So now next up I just select this one, and now I need to figure out that there is one more parameter that we need, that is your angle. Okay, and that should be like float angle is equal to, now as I mentioned you that this angle should be in radian format. Okay, so what I need to write down, that I just need to write down one global variable, that is pi divided by 4. Okay, so that is 180 degree divided by 4, so that is 45 degrees. So it is the value equivalent, radian value equivalent to 45 degree. Okay, so I will get these things over here. Now I need to apply that vertical spacing and horizontal spacing, and I just store those values into variable like vertical spacing is equal to, that should be your tile width divided by sine angle. Similar manner we have float horizontal spacing is equal to that is your tile length, half of tile length, that should be multiplied with 0.5 and divided by sine angle. Okay, so I just calculate those parameters. Now I need to create two vector variable, and that basically covered your store basically your position as well as normal information. Now next thing, now I'm going to run, as we need to create those points in rows and columns. So for that reason we need to run this particular process into a for loop. So I just need to write down for, and here as we need to generate rows and column points, so we need to generate two loops, one for rows and one for columns. So for loop inside one for loop. So here I am start with integer, create one variable, that is row is equal to start from 0. Row should be less than number of rows that you defined over here, and row plus plus. Start this, and definitely for that I always prefer that close that one. Create one more, that is for integer column is equal to 0 semicolon, column less than number of columns, and column plus plus. Again that should be also start and close. Now here as you see in that particular pattern we have offset in alternative columns. Okay, and to identify that thing, likewise odd and even things, we just need to write down one if condition, that if column modular 2 is equal to 0 0. So whenever you get like 0 2 4, that kind of value, it just jump inside this particular loop. And what we need to do here, we need to define that, okay, that position that we already created over here, this position vector dot z should be row into your vertical space. Okay, as well as I just need to write down else, and in this else condition I just copy entire thing, Control C, Control V, and here we need that offset, and that offset should be, it is always preferable that you apply brackets and plus the offset is vertical, whatever that vertical spacing we have, divide by 2 or multiply with 0.5. So here I just divide by 2. So now we have that entire thing in a proper manner. Now what we need to do is that we need to define our position x. Okay, so position x should be your column into horizontal spacing that we already calculated. And definitely now next thing is that we need to generate our point. So that is integer pt is equal to add point 0 geometry, and I just need to define that position. Okay, I just click outside of this and we will get that pattern. Okay, so now what am I going to do is that I just copy to point apply this tile as my geometry, this as my point. But right now I get like this. Okay, we are not getting that angular rotation of your tile. Okay, and to do that, what we are going to do, I just template this one, activate your attribute wrangle so we can see that points and this at the same time. Now see here, what am I going to do is that in this particular, as we know that uh, where we have this particular, that first row, first column, second column, we need that direction should be in 101, and here we need -101. So we just define within this if condition that okay, that normal dot x is equal to 1 for this condition, and normal dot x is equal to -1 in this condition, and we have normal z is equal to always 1, so that is fine. Okay, but now uh, this is just a variable. We need to define the value of that variable into your attribute, normal attribute. So to do that, so see right now if I click on this display normal, we are not getting anything visually. But now if I apply like set point attribute in bracket 0, your attribute name that should be normal, so it defined by capital N, your pt that is your point number, comma, the value that you want to assign on to this particular attribute that is normal. And now if you click outside, see now we get that direction of normal, and based on that normal direction we will get this pattern. Okay, so now if you check, we'll get this pattern, and maybe if you change your values, it automatically set. Okay, so right now I just set 1.3, 0.2. Okay, so now I just apply some more modification onto this. So likewise, it is always preferable that as I am going to apply some texture onto this particular tile, so we prefer that we apply one UV unwrap, and let's check. Okay, so this is the UV for this, so that is completely fine. And let's do some border things and everything onto that. So for that reason, I'm going to create one for each connected piece. What am I going to do here is I just apply bit poly extrude. I just click onto this button, and here I just apply like insert should be maybe 0.003 or a little more, that is fine. And I just set this out front should be in one group and outside should be in group. So we just store the information that extrude side and extrude front. Now what am I going to do is that here we have all the thing like this. Now I'm going to apply one color onto extrude side, which may be black, and that should be on primitive. Okay, so we will get this bordered. Now as I'm going to create shader in Material X, and for that reason we have to move into Solaris workspace of Houdini. So what I always prefer that I just store this information into separate entity. So that should be reflect on your Solaris when you call this. So for that reason, I just apply one name operator in which I just define my group, that is extrude front, and I just name it as wooden. Create one more group, and that is your extrude side, and maybe I just name it as border or edge or whatever. So right now I just set it as border, and I just name it as null out tile. Okay, and I just copy this, Control C. As well as what I prefer here is that I just press Control 1 to bookmark this particular view, so that whenever we need to jump in this particular area, we can just press 1 and we immediately jump over here. Now next thing is that I just move into my Solaris workspace, and that should be on stage. Okay, so this is my Solaris stage. Now I need to call shop import, and here I just paste that tile. So now we have this tile to be imported in our Solaris workspace, and if you check this shop import, in which we now get this border and wooden different primitives, and I just name it as herringbone, and now we will get this component is herringbone, in which we have two more primitive, that is border and wooden, so we can apply different material onto these two things. So now next thing that we need to create one material library, and I just right click material, use material X builder, and I just name it as material X wooden. Go inside this material, and this is my basic parameters and everything. So I again jump out of this stage. I prefer to apply assign material. Just select this wooden primitive. In material path, I just assign this material wooden. Now to check this particular shader, I am going to apply one DOM light. Select this one, go to HDRI, and for this example, I just use one rainforest trail. Just zoom this one and prefer to render through Karma CPU right now. So right now I'm not getting any texture onto that, as I am not assign anything right now. So I just need to go inside this material library, go inside this one. Now to apply appropriate texture onto this styling, I need to call attribute UV attribute, and for that reason I just call material X texture coordinate. Okay, so now if I apply this information into my base color, see, I will get this UV information. Okay, so I just cut it down, and right now I just apply one unified noise, in which we have this texture coordinate. So I just apply this texture coordinate and apply base color. So I will get something like this, and might possible that if you change your frequency maybe 2 and here 20, we will get something like this. Okay, but the issue with this is that we will get similar pattern on every tile. Okay, and this is bit awkward, or this is not look natural. Okay, so what we need here is that first of all, we need two parameters should be in little variation formation, that is your frequency. Okay, so might possible that if you have one frequency or maybe two, or here maybe 10 to 20 20 range in different tile. So I need basically random frequency, as well as I need a bit changes in my UVs. Okay, and to do that I need to jump again onto my main object, or my that shop network. And here what I prefer, that first of all I'm going to create one attribute that help me out to generate different frequency. So now what am I going to do is that I'm going to create a attribute, and I will show you that how to use that attribute into Solaris or Material X. So I just call attribute randomize. So by default it's give you that CD. So I just net and I just name it as noise frequency, and that should be in 2 dimension as we have only U and V. And here I just set maybe 1 and 2, and maybe here you can change it to 20 and 30. As well as right now, as I mentioned you, that this UV has same value, same information, so that should be bit changed. So what I prefer over here is that I just apply, or I just convert, or I just set this particular UVs into UDIM. Okay, so for that reason, so right now if you check your UVs, it locate in the same space and the same location. Okay, and to do that, what I prefer, I just select this for each begin, and here I just click on this create meta import node. So it will call your, it basically fetch your iteration information and everything. And I prefer that here I just create one null operator, and I just add spare input. I just call this for each begin metadata into my spare input. I'm going to create one parameter like float. Name it as iteration. For that I just apply I apply accept. In that I just need to call detail. That should be -1. So -1 basically call your spare input 0. Attribute, that is your iteration, and 0. Okay, so now I get this iteration information. So now I just copy this parameter, and here I'm going to create one attribute wrangle. Now as we are store our UV information in vertices, it is preferable that you run this particular expression on 2 vertices. So I just right click and paste relative reference. So basically it just call that iteration information, and I'm going to store that into one variable. Now I just call float x move is equal to I %10, and float ym is equal to floor I divide by 10. And I just create one vector in variable, that is vector move is equal to set xm ym and 0. And now you have that attribute uv plus equal to move. Okay, so now see, you will get those UVs like this. Okay, now I need little more variation into that. So for that reason, I just apply like plus random I, and see, you will get like this. Okay, so every that tile has different UDM as well as different position in file. Okay, as well as I just created one attribute, that is noise frequency. So I'm going to use that in my material. So now if you checked in this particular Solaris, we will get different noise. Okay, so due to that UV, we change that UV. So based on that, we get this. But right now the frequencies are same. So for that reason, I just go inside this material and I am going to call that attribute in my material X. And for that, I am just using one geo property value in which I am going to write down the name that I assign, that is your noise frequency, and that is your vector 2. So you have to define that signature for that. And now I'm going to apply that into my frequency. Okay, so now you get some different frequency on your tile. Okay, but now we need that wooden pattern structure onto that. And for that reason, I'm going to create one more unified noise 2D. I just apply that outcomes of that noise into this texture coordinate. I apply that onto my base color. And in this particular unified noise, I just copy this parameter, paste it over here in that Y, and I just apply value to be maybe 10. And see, you will get that patterns like wooden pattern. And now you can play with those values. So right now I just put as it is. Even you can go into your shop network and change that randomized frequency and everything. Now it is preferable that I'm going to apply some color based on this. But before that, as you see here, we are not getting a proper dark value of this. And for that reason, I am just apply one material X range in which I just set my input low maybe 0.25. So 0.25 will become 0. So now I'll get little more darken area, or maybe here you can also change maybe 9.5. So we'll get little more brighten area also. So now next thing that we have to apply some color onto this. So for that reason I'm using one color ramp in which I just click onto this, select this one, change bit hue, little darken like this one. Here I prefer little better one, and maybe little more. Okay, and you can use this outcomes, that gray outcomes, as your displacement map also. So I just prefer to apply this as my displacement map. Okay, so I need to decrease the value like minus 0.001, something like this. So you will get that pattern. And definitely you can play with specularity, roughness of your specular, diffuse roughness and everything. Okay, but the important thing is that you get that pattern, wooden pattern. Now, if you need some more detail, likewise, I need little noisy pattern, little noise on those edges and everything. So what we can do for that, I can use this coordinate. I'm going to use one more noise. You can use this or not, that is up to you. Now I just apply this texture coordinate, and for reference perspective I just apply this as my base color temporary, so I can get the pattern of that noise. So I just select this unified noise, ununified noise, and in that I'm going to change my frequency like 150 to 2000. So we will get this kind of pattern. Now what I need to do is that again I applied this to as my base color, and now I'm going to use this particular frequency to be offset for that second noise. Now you will get bit noisy pattern like this. Okay, so it's total up to you. You want to use that or not. I just temporarily remove that one. Okay, even you are not happy, you are happy with this ramp but you are not happy with the hue. For that you can use color correct operator, and which you can change the hue. Maybe you can change the gamma and you will get the result. Okay, so definitely I just lock this one, view, just press 1, select this attribute triangle, and might possible that I just change this numbers of column, maybe numbers of rows, maybe 30. And you just set your camera, like here I just create new camera, lock that one. So that's how you can create wooden herringbone pattern. Hope you like this tutorial. See you soon with another tutorial. Thank you.